All right, today we're diving into some really fascinating new research that smashes together two of the biggest technologies out there, blockchain and artificial intelligence. Let's get right into it.
So think about this for a second. What if we could take one of the biggest knocks against crypto, its insane energy use, and flip it into one of its greatest strengths? That's really the core question we're looking at today. Can we actually transform the work used to secure a blockchain into the valuable work of building powerful AI?
To really get what's going on here, you've got to understand this fundamental shift. On one side, you have proof of work, which is what things like Bitcoin run on. Miners are just solving these abstract math puzzles that honestly have zero value outside of securing the network. It's just brute force, and it is incredibly wasteful. But on the other side, you have this new idea, proof of useful work. The goal here is to swap out those useless puzzles for actual real-world problems. That way, all that energy gets imbued with real, tangible value.
And look, let's be real, this is not a small problem we're talking about. The energy footprint of these big blockchains has become a legitimate sustainability crisis. It sparked huge controversy and even led to bans in some places.
Just to put a number on it, the Bitcoin network, all by itself, burns through about 120 terawatt-hours of energy every single year. That is roughly the same amount of electricity that a whole medium-sized country uses. And all of that power is just going towards guessing the answer to a puzzle. It's kind of wild when you think about it.
Okay, but this is where it starts to get really, really interesting. Researchers have been trying to figure out how to redirect all that computational muscle. Instead of having all these powerful computers just guessing numbers, what if they were doing something productive? Like folding proteins, modeling climate change, or, as we're about to see, training machine learning models.
And that brings us right to the heart of today's explainer, proof of learning, or POL for short. It's a specific kind of proof of useful work, where the work required to secure the blockchain and earn rewards is literally the successful training of an AI model. So you're not just mining crypto anymore, you're actually pushing artificial intelligence forward at the exact same time.
So you're probably thinking, wow, that sounds amazing. Why aren't we doing this everywhere? Well, it turns out there's a pretty massive roadblock that has had researchers stumped for a while. It's something known as the proof of learning trilemma.
See, the thing is, for a system like this to actually work as a consensus mechanism for a blockchain, it needs to do all three of these things at once. It has to be super secure, so people can't just fake the AI training. It has to be efficient, because if verifying the work costs just as much as doing it, what's the point? And you need to be able to control the difficulty so that blocks get produced at a nice, steady pace. And getting all three of those to play nice together? Yeah, it's been next to impossible. Until now.
And this is where the researchers behind the paper we're looking at today just completely changed the game. They decided to stop trying to smash through the trilemma. Instead, they just sidestepped it by rethinking what security even means in this context.
This quote right here really captures the whole genius move. They said, forget trying to make cheating impossible. That's the trap that leads to the trilemma. Instead, what if we just make cheating unprofitable? The whole goal shifts from building something cryptographically invincible to something that's just economically rational. I love this analogy because it makes it so clear. Previous attempts were all about building a vault that was physically impossible to crack. This new approach, it builds a regular vault, but it just makes it so that the cost of the tools you'd need, the crazy high risk of getting caught, and the penalties, it all adds up to robbing the vault being a completely terrible business decision.
So how does it actually work? Well, the mechanism itself is beautifully simple. Okay, so the AI trainer, who they call the prover, breaks the whole training job down into lots of little stages. After each little piece of work, they post a cryptographic hash. Think of it like a unique, tamper-proof digital receipt for that stage. Then later, a verifier shows up and just randomly picks a few of those stages to double-check. And because those checks are totally random, the prover has no idea which parts are going to get inspected, which means they have to do all of the work honestly.
So yeah, it's a super efficient system, right? The verifier barely has to do any work. But, and this is where it gets really clever, this elegant solution creates a brand new kind of sneaky problem of its own.
And they call this the verifier's dilemma. Think it through. If the economic incentives work perfectly and no prover ever cheats, then what's the point of verifying? It just becomes a waste of time and money. So a rational verifier would just start approving everything without checking, just to save on their own costs. But of course, the moment all the verifiers stop checking, cheating suddenly becomes profitable again, and the entire system could just collapse.
It's that classic paradox, right? It's like if you know for a fact that nobody is cheating, why would you ever pay a security guard? The guard is so good at his job that the problem he solves disappears, which makes his job seem useless.
But of course, he's the reason the problem is gone in the first place.
So how do you solve that dilemma? Well, the paper's solution is just brilliant. They turned it into a game, specifically a game that a lot of folks in cybersecurity will know well. Capture the flag.
Okay, so here's how it works. This system actually requires the prover, the AI trainer, to intentionally stick a few tiny secret markers or flags into the training process at random points. Now, these flags are designed to be totally harmless. They don't mess up the final AI model at all. But here's the kicker. Verifiers get paid specifically for finding these flags. This gives them a real, tangible reason to always be checking the work, even if they assume no one is actually cheating. And of course, while they're hunting for these harmless flags, they'll also naturally catch any real cheating that might be going on. It's a genius way to make sure the guards are always walking the beat.
So, let's zoom out for a second. What does all of this actually mean when you put it together? Well, by neatly solving both the trilemma and the verifier's dilemma, this research does a lot more than just make crypto a bit greener. It really opens the door to something way, way bigger.
And this isn't just a cool idea on paper. They actually proved that it works. Just look at this graph. It's showing the potential profit or utility for a cheater. That top teal line shows that if you only check one little part of the work, a cheater can get away with doing almost nothing and still make a profit. But watch what happens as you increase the number of random checks to 5, 10, or even 50. The potential profit for cheating just dives deep into negative territory. It becomes a money-losing game. The takeaway is simple. Honesty rapidly becomes the only smart move.
And when you stack this new incentive-secure method up against the other ways people have tried to solve this, it's not even a fair fight. You've got things like zero-knowledge proofs, which are perfectly secure, but the computational overhead is just astronomical, like 1,000 times more work. Other approaches like optimistic ML are more efficient, but they slam right into that verifier's dilemma we talked about. But this new method, it gives you solid security with an incredibly low overhead. We're talking less than a tenth of the original work, all while neatly sidestepping the dilemma.
And that's the real punchline here. This is so much bigger than just crypto. This research basically hands us a blueprint for a global, decentralized, and most importantly, a trustworthy marketplace for AI computation. It means anyone, anywhere, could rent out their computing power to train AI models for other people. And the system itself guarantees, through pure economics, that all the work was done honestly. It's like a foundational layer for a whole new, democratized era of AI. So it really leaves you with this one big, kind of mind-bending question. We always think about digital security in terms of building these impenetrable firewalls and unbreakable codes. But what if the best, most scalable way to secure our digital world, and maybe AI itself, isn't about forcing people to be good, but about designing systems where being honest is just, by far, the most profitable thing you can do?